So a common difficulty that shows up with MVT problems is, especially for table problems, it's very easy to confuse when you should use the mean value theorem versus when you should use the intermediate value theorem. So in other words, MVT versus IVT. So here I have an example. Function h of x is continuous on the closed interval 0 to 20 and differentiable on the open interval 0 to 20. That statement alone has already got me thinking of the MVT, but it does also meet the conditions for the hypothesis of the IVT. We're then given a table of selected values of h, and we're asked two different questions here. We're asked to explain why there's a value of b in the open interval 0 to 20 such that h of b equals 10, and then explain why there is a value c in the open interval 0 to 20 such that h prime of c equals -1. Some things that help me decide whether I should be using the intermediate value theorem or the mean value theorem are what are they asking me values about. So here we're being asked about the function. Whereas here we're being asked about the derivative. If you remember, the intermediate value theorem is specifically about the function values, whereas the mean value theorem, while function values are part of it, is really about rates of change, which means it's about derivatives or it's about slopes of secants. And it's the slope of the secant that the function values show up in, but it's really about derivatives. So when I see a table problem, if they're asking me about function values, and the table talks about function values, I'm going to be using IVT. Whereas if they're asking me about the derivative of what's in the table, this is leaning me to consider using the MVT. So if I'm talking about the IVT, first I need to make sure that I meet the hypothesis. Well, h is continuous on the closed interval of 0 to 20. In order to have a value of 10, I need to find endpoints where I'd have one above 10, one below 10. And what I can see is right here. So if it's continuous on 0 to 20, it is continuous on 10, the closed interval 10 to 15. While h of 10 is 16, h of 15 is -4. And since the h value of 10 is between -4 and 16, the IVT guarantees that h of b will equal 10 for some b that's actually between 10 and 15. The difference with an MVT style problem is, even though my table is about h, they're asking me about h prime. So h is continuous on the open interval, or on the closed interval 0 to 20, differentiable on the open interval of 0 to 20. But then I need to see, is there a slope of a secant in here that would give me a value of -1 so that the MVT would guarantee the derivative would have that. Well, if I go 0 to 20, well, that change in y would be 8 over 20, well, -8 over 20. That's not going to equal -1. If I go from 5 to 20, that gives me a slope of -15 over 15. Well, that's -1. So what I look at here then is right here that h of 20 minus h of 5 over 20 minus 5. And remember, I have to show the subtraction to communicate that I'm finding a slope of a secant here. Well, that's going to be equal to -9 minus 6 over 20 minus 5, which is -15 over 15, which is -1. So the MVT guarantees that H prime of C will have to equal -1 somewhere between 5 and 20, which means it's also somewhere between 0 and 20.